Hey, everybody. So we're looking at our CFA on all of the circle content we've been doing. Um, Throughout this review, I'll be going over the class example problems. So, make sure to do those with me, make sure to enter those answers. And then, as I always kind of recommend, I would bounce back and forth after I do an example. It's not a bad idea then to try some problems on your own and then the next example and so on. Okay, so yeah, this review covers a lot of content. It's basically all of chapter 15 and 16. Okay, all of the circle stuff we did. All right, I don't have a class example for this, but the first thing that it starts out with is just parts of circles. Okay, where it's going to throw something at you on a circle, and it's going to ask you, do you know what that is? For example, this is a radius. All right, so that's what these are about. Yeah, so if you have any questions on those, just talk to me. But I'm not really going to go over any of those, I guess, besides the one I just looked at. Okay. After this, another thing that it gets into that I'm not going to go over, I guess, formally is looking at central angles. Okay, central angles are really straightforward. If you guys remember, if we are given the measure of a central angle, say it's 42 degrees, then the measure of its intercepted arc is going to be the same. Okay, your problem isn't going to look like mine right here, but my answer for this one would be 42. If the angle's 42, the arc is 42, and vice versa. Okay, cool. But yeah, let's look at the first one I do have as a class example, looking at inscribed angles. Go ahead and click on this. All right, so first thing, if you guys remember, an inscribed angle is an angle on the edge of the circle. Just to give you just a visual of what we learned, it was this one right here. Again, if you guys remember, it was just a really simple rule. The measure of an inscribed angle is half the measure of its intercepted arc. All right, so taking a look at this problem, you don't have to draw these circles, by the way. Some of these problems, it wouldn't be a bad idea. All right, but on this, I'm just going to kind of write in the info. This one is giving us the measure of the arc. It's saying arc KM is 74 degrees. Okay, asking us to find the measure of angle, KNM, this inscribed angle. All right, well, there it is, right? We know that the angle is half the arc, so I can literally just take 74, divide by 2, and it looks like this is going to be 37 degrees. Okay, so you can go ahead and put in that answer. Right. Remember, the opposite also is going to happen. There's going to be problems that give you the measure of the angle and ask you for the measure of the arc. If the angle is half the arc is double the angle, right? So, in this case, if they gave us this as 37, the arc would be double that, 74. Okay, so try not to get those two things mixed up. Okay, yeah, let's keep moving along and go ahead and go back. If you'd like to pause the video, try out some inscribed angle problems, I would encourage that. All right, cool. So from here, we're getting into the next class example. Let's go ahead and just click on that. All right, so this one is giving us two, I guess you can think of as chords crossing one another. Okay, but these are the angles inside the circle problem. All right, so just to kind of go back, okay, we're looking at these types of problems right here. Okay, so if you guys remember, the measure of the angle inside a circle is half the measure of its two intercepted arcs. I think of it as the one in the front and behind, added together. Okay, so let's see what this one is giving us. All right, this is a type of problem where it wouldn't be a terrible idea just to draw yourself a simple circle. Okay, it's giving us the measure of angle LQ. Let me scroll this down. Okay, so sorry, did I say angle arc LQ? So that's giving us the measure of this arc is 143. Okay, and it's giving us the measure of the angle in the circle. Okay, angle RAI starts at R, goes around A to I. That's this angle. All right, so this one is 97. Okay, and what it's asking us for is the measure of the other intercepted arc. Okay, that's what we're looking for, or we can call it X. Okay, it's important to realize what info we have because now we can start plugging this into, our formula. Okay, we know the angle in the circle. That's the first thing that's going to go in our formula. So let's go ahead and do it. The angle in the circle is 97. Okay, just by the way, I need to see all of this work on your piece of paper. For any problem that has you finding X like this, show the work. At the very least, show the equation. Okay, so anyway, the angle equals half the measure of the two arcs added together. It doesn't matter what order you add them. I'm going to do x plus 143. Okay. From here, if you guys remember, we have two options. We can distribute the 1/2. Okay. If I did that, I would end up with more fractions or decimals. Or we can get rid of it by multiplying by the reciprocal. Okay. And that's what I'm going to do. I think that's going to give me an easier problem. Okay. So multiplying by the 2/1, 2 times 97 gives me, 194. Over on the right, these are gone now, and we have x plus 143. Now we can solve for x by getting rid of the 143 by subtracting. So minus 143, it looks like we're going to get 51. I'm going to flip it around. Okay, or really, you can just go in here. Okay, so yeah, the math isn't terribly, difficult. It's getting everything plugged into the correct formula in the correct way. So just take your time on that. Okay, so let's see. Let's go ahead and go back. Right. My advice would be to go ahead and try out some of these other problems dealing with what we just saw. Okay, next class example is this guy right here. Go ahead and click on that. All right, so first thing to realize, we are dealing with an angle outside the circle. All right, so just a quick reminder, here's our formula for the angles outside a circle. Right here. Okay, the only difference is that when we have an angle outside the circle, those two intercepted arcs are subtracted from one another. All right, so let's see what content, or I guess what values they're giving us on this. All right, so let's see. This one is giving us the measure of arc GD. So it's saying GD is 150, so that's this arc right here. Okay, and it's giving us the measure of angle W. Okay, so it's giving us the angle outside the circle, 49 degrees. And it's asking us for, the other intercepted arc. Okay, which I'm just going to call X. All right, there is our info. Drawing it and putting those numbers on the circle, I think is really helpful. I would highly recommend doing that. The other thing I want to say, there are some problems that instead of asking you for an arc, some of them will just ask you to find the angle. Okay, and those will be a lot more straightforward. You'll get the two values of the two arcs. All right, so I'm doing some of the more difficult ones. All right, so let's plug it into our formula. Angle equals half the measure of the arcs subtracted. So we know the angle is 49 equals 1/2 of our two arcs subtracted. If you guys remember one important thing, we need to take the bigger arc and subtract the smaller arc. All right, if we don't do that, we're going to end up with a negative answer and it'll be wrong. Okay. All right, again, I could distribute. I'm not going to. I'm going to get rid of the fraction by multiplying by the reciprocal. Okay, so it looks like we got 98 equals, those are gone. I got 150 minus x. Okay, from here, we need to get rid of things in the correct order. The first thing is this 150. It's a positive 150, right? So we need to get rid of it by subtracting 150 from both sides. Okay, so we have 98 minus 150, and that gives us negative 52 on the left. On the right, we have still negative x. Don't forget that negative. Okay, and we basically have our answer in front of us. If you guys remember, if we want to change the sign on one side of the equation, we can do that as long as we change the signs on the other side. I'm going to flip around. X equals 52. Okay, so again, go ahead, scroll down, and put that in as your answer right here. All right, let's go back up and keep moving. Let's see. I don't want to lose my spot. Okay, so this is one we just did. I would try some of these out if you'd like. Let's try this intersection of chords. Go ahead and click on this one. Okay, so big thing to realize. We are now shifting gears in the content or the values that are given to us. These problems start giving us, instead of angles and arcs, they start giving us lengths of segments. All right, so let me just quickly remind you guys. Okay, this is where we get into the chord product theorem, the secant product theorem, that sort of thing. And this is what we're dealing with on this song or this problem. Okay, so what we're doing, we're multiplying the two parts of one chord and setting it equal to multiplying the two parts of another chord. All right, so let's see. On this one, these problems are the little bit more difficult ones. They're giving us, I guess, more complex values. And if you guys notice, ultimately what they want us to do is find LJ. They actually want us to plug it back in and find the length of a segment. Okay, we'll do that after we find X. Okay, so let's go ahead and set this up. I'm going to go ahead and multiply the two parts of one chord. Okay, so 6 times 3x. And set that equal to multiplying the two parts of the other chord, 4 times 4x plus 1. Notice how I'm putting these in parentheses, especially this one is important. That 4 is going to be distributed. Okay, and that's going to be our next step. Okay, so on the left, 6 times 3x gives me an 18x. On the right, 4 times 4, 16. 4x would be a 16x. 4 times 1, positive 4. All right, next thing, hopefully you notice variables on both sides. We need to get them to the same side. I'm going to choose to move the 16x. Okay, so this is giving me a 2x equals 4. And then divide by 2, x is going to equal 2. Okay, be really careful. It would be really tempting to plug that in for your answer. It's not your answer. They want you to find LJ. All right, and if you guys notice, LJ is this entire segment here. Okay, so I need to plug it back into here. So off to the side, I'm just going to do it 4 times x plus 1. Okay, and don't forget, also we need to add 4. All right, and x is 2. So we're going to plug that in right there. Okay, so it looks like we got 8 plus 1 plus 4. Looks like the length of this thing is 13. Okay. All right, cool. So yeah, just be careful with these problems. Again, these are the more difficult problems that I'm doing. You'll notice some of the ones that are thrown at you don't have as complicated values. You'll still use the same formula, but they'll be a lot more straightforward. Okay, so let's see where we're going from here. All right, so I just did this one. Let's move on down to this next class example. All right, this problem is dealing with the secant property. All right, so quick reminder. Okay, secant is when we take the outer segment and we multiply times the entire secant line. Okay, that means adding together the two parts of the line. All right, so let's see what happens on this one. All right, again, some interesting values. That's okay. And also, this problem wants us to find the length of a segment df. We'll do that after we find x. Okay, so let's start setting this up. I'm going to start with this secant line here. All right, so taking the outer segment, 4, and multiplying it times the entire line, which isn't just x minus 1. It's x minus 1 plus 4. Okay, and then on the other side, doing the same thing. Taking the outer segment, 3, and multiplying it times the entire line, which isn't just x plus 2, it's x plus 2 plus 3. Okay, if you can get this far, I think you'll be just fine. Be careful setting these secant problems up. All right, cool. So some simplifying to be done in the parentheses, so I'm going to do that first. So we got 4 times x, negative 1 plus 4 gives me a positive 3. Over on the right, 3 times x, 2 plus 3, we got a 5. All right. By the way, I do recommend doing this math before you distribute. I sometimes see people distribute before simplifying, and they end up with a lot more just numbers, and they kind of overcomplicate the problem. All right. So anyway, distribute the 4, distribute the 3. Let's see what happens. We got a 4x plus 12 equals a 3x plus 15. Remember, distribution is multiplying. Be careful. You might be tempted to add. All right. Variables on both sides. I'm going to move the 3x over to the left. 4x minus 3x is a 1x. I'm just going to write it as x. Bring down the 12 on the right. These are gone. I got a 15. Okay. And then subtract 12 from both sides. X equals 3. All right. Be careful. Again, not your answer, but we can now plug it in and find what they're asking for. They want us to find DF, which is this entire segment. All right. So, plugging in 3, you can probably just do this in your head. If this is 3 here instead of X, we got 3 minus 1, which is 2. 2 plus 4, 6. All righty. Cool. So let's keep moving along. Again, there's a lot of stuff here, but we're actually, I think we're getting close to the end. All right. So let's see. I have actually just one more class example I want to take a look at. All right. Go ahead and click on this one. All right. So this problem is getting into the tangent secant problems. So if you guys remember on the tangent secant, this is when we square our tangent line, and then we do, the typical thing with our secant line. All right. This problem, I guess we'll see. The reason I'm doing this problem, I guess I'll spoil the surprise. This problem is leaves you with a quadratic, and you need to use the quadratic formula. Okay. There's other tangent secant problems on this that are way more straightforward and a lot easier than what you're about to see. But there will be one quadratic equation problem on your test. That's why I want to do this one with you. Okay, so let's set it up. First thing, let's square our tangent line. So we got 6 squared. Okay, over on the other side, let's do our secant rule, outer segment times the entire line, x plus 5. All right, we'll do some simplifying here, or, distribute the x, square 36, or square 6 to get 36. X times x is x squared, x times 5, 5x. Okay, here's now the issue. We are stuck with this quadratic. All right, so what do? Well, let me remind you. Quadratic formula. First thing, we need to get this thing in the standard form. That means getting all of the terms to one side and then a 0 on the other side. All right, so let's do that. Okay, on this problem, the only thing that, I could really move these up to either side, but the quickest thing to do is to get the 36 and move it over to here. Okay, so what that happens is it gives me a 0 equals x squared plus 5x minus 36. Okay, notice the order that I'm putting these terms. This is the order that you have to use or to be in standard form and to identify A, B, and C. Okay, so yeah, let's do that. Let's make it obvious. So invisible 1 here. So A is going to be 1, B is going to be 5, and C is negative 36. If there's negatives there, don't forget them. Okay, cool. So from here, now we can start plugging this stuff into the quadratic formula. All right, here it is. Make sure you have this in your notes. All right, don't overcomplicate it. We're just going to get everything into its right spot. So x equals negative b. Let's just go ahead and start plugging this stuff in. So x equals negative b. Our b value is 5, plus or minus the square root. Okay, quick reminder, b squared minus 4 times a times c. So b again is 5, so 5 squared minus 4 times a, 1 times c, negative 36. Okay, all over 2a. And a again is 1. Okay, so on this step, I'm just going to do some simplifying, basically focusing on doing the math inside or underneath the radical. All right, so let's see. This is a negative 5, right? Plus or minus underneath the square root. Okay, just a reminder what I recommend, squaring this number and then multiplying these 3 numbers, doing it one at a time. 5 squared is 25. And let's see, negative 4 times 1 times negative 36 gives me a positive 144. All divided by 2 times 1, 2. Okay, cool. Next thing I like to do, or next thing we can do is deal with the rest of this radical. Okay, so we still have this negative 5, plus or minus. Okay, I like to do both of these steps at once, adding these numbers and then taking the square root of that. 25 plus 144 gives me 169. Okay, so you don't have to write this, but this is giving me the square root of 169, and the square root of 169 is 13. Okay. And then on the bottom, we still have that too. All right. Basically, last thing is breaking this into the two equations that we have sitting in front of us. We have a negative 5 plus 13 divided by 2, or we have x equals a negative 5 minus 13 over 2. All right, let's do the math and see what happens. Okay, so let's see. 13 minus 5 is 8. 8 divided by 2, we get 4. And then, or over here, looks like we get a negative 18 divided by 2 as a negative 9. Okay, here's the big thing. Because we're dealing with lengths of segments, it doesn't make sense to use the negative value. Okay, so we are not including this as one of our answers. Okay, our answer that we're going to plug in or write into Delta Math is 4. Alrighty, that is probably the toughest part of the review, and I just want to say it again. I've been doing what I think are the most difficult problems. They are not all as hard as what you are seeing in front of you right now. I just want you to know that. All right. As far as my class examples are concerned, though, that is the last one I have. Here's the thing from here. The test, after you guys try one of these, gets into circumference, arc length, area, and sector area, the stuff we just tested on. All right. So just a reminder after this, this is what the end of this test deals with. I think these problems are really simple. Okay. Remember, it's just about using the correct formula and plugging in the values and you're good. Like none of these are terribly difficult problems. All right, so I am going to leave these to you, but if you have any questions, obviously talk to me. Cool. So yeah, that's the review there, guys. Try out these problems, ask me questions, and you'll do just fine on this test. All right, we'll see you.